all of your characteristics so that we can actually end up graphing this. So do we remember what the steps were that I went over the first time that I taught my lesson? Okay, so what was step number 1? Well, before that. We wanted to ask ourselves, is it in standard form, right? So is this equation in standard form? So if you guys have the equation, I'm going to turn this on. Okay, so is it in standard form? And we said yes, so we don't have to move anything around. Alright, so 2, we are going to find our A, B, and C. So in this equation, what is our A value? 1. And how do we know that? Because there's a 1 beside the x squared term, right? Right. Okay. So what's our B value? 4. And that's because it's beside the x term. And then what's our C value? 3. Alright, so next we decide whether we have a maximum or a minimum for our graph. So how do we decide whether we have a maximum or a minimum? C. So this C is positive 3. So are we going to have a maximum or are we going to have a minimum? We're going to have a minimum, right? Because if we have a positive, our graph's going to go up. So that means that we're going to have a minimum point. Alright, next we find the y-intercept. Do we remember how to find the y-intercept? It's C, right? Or you could plug in 0 into your equation and solve. So what's our y-intercept? 0, 3. Good job. This is all coming back to you slowly? Yeah. Alright. So next we're going to find our axis of symmetry. What's that equation that we use to find our axis of symmetry? So x over 2a. So when we plug ours in, we get x equals negative what? 4 over 2 times 1. So that's going to give us negative 4 over 2, which is going to give us negative 2. Good job. So then we rewrite x equals negative 2. And we have to make sure that we do that because the axis of symmetry is a vertical line. Okay? So after we have our axis of symmetry, we can find our vertex. What are we going to do to find that vertex?
Plug in negative 2 for every difference.
Yeah. So we're going to plug in negative 2 into our original equation. So we have negative 2 squared plus 4 times negative 2 plus 3. So that's going to give us y equals negative 2 squared is 4 plus 4 times negative 2 is negative 8 plus 3. So we get 7 minus 8, which is negative 1. So what's our vertex? Because we have to write it as a point, right?
Would it be negative 2, negative 1?
Negative 2, negative 1. And we know that because the x that we plugged in was our negative 2, and then we solved down for our y, which was negative 1, so we have negative 2 is our x and negative 1 is our y. Alright, and last but certainly not least, we can find our x-intercepts. Now, I haven't been here for the past week, but how do you guys, what do you guys know to do to find your x-intercepts? What have you guys been doing in class?
It's like when they ask us when the equation hits the ground.
Oh, I know the answer.
Polyroutes, yeah. You can factor, you can use your quadratic formula if you know how to use that. Okay, so how are we going to solve our equation up here? How would you like to solve it?
Polyroot.
Polyroutes? Okay.
Someone want to go up there and put their calculator onto the.
I got it already.
Thank you, Melody.
Yeah.
Yeah, you're right, Taylor. Zoom it in just a touch more, Melody. A little more.
I did what?
There's 2 plus signs here. So those are our roots.
No, it doesn't. I think it's not gonna get
What do you think?
-1.
Mm-hmm. It's actually gonna be both. So when we figure this out, we can see that we have an x equals -3 and x equals -1 as our roots for our equation. We could also, if we go back and look at this, we could graph our y equals x squared plus 4x plus 3 and just see, like on our calculator, and see if these are actually our x-intercepts, just to check to see if we're right, okay? So these are going to be our x-intercepts. So
Melody,
Now-
Melody, you can grab 2 things out of the box if you want to.
so now, what we're going to do is we're going to go ahead and take all of this information and we're going to graph our graph, okay? So let's see, where should we start? We can start out with our x-intercept. So if we turn over, our x-intercept was 0, 3, so we go up. We have a point right there. Okay? And then what was my axis of symmetry? -2. Okay, so we go over to x equals -2, and we put our little dashes for our axis of symmetry, just so that we know that any x's on the left side of my axis of symmetry, or any points on the left side of my axis of symmetry, have to match the points on my right side. Okay? What was my vertex? -2, -1. So we go over to -2 and down -1. Our point. And then what were my x-intercepts? So 0, -1, and 0, -3. Okay? So if I look, I know that I can plot the point, -1, 2, 3, 4, 1, 2, 3. I can plot the point -4, 3 because it matches our y-intercept, because anything that is on the right side has to match the left side, and the same left side has to match the right side. So now we can just kind of connect our dots, and that's our parabola. Okay? And we included all the information that we calculated for, and we didn't even have to use the table this time, right? So it's a little easier. Cool. Alright, so this was just kind of start you off, because you will be using the same steps in the activity that we're going to do today. So today we're going to be exploring different ways that you can transform quadratics and their graphs. And what I mean by transform is that we take the parent function y equals x squared, and we're going to add constants, numbers, to make them move somewhere on the graph, okay? And so what you have probably noticed was as we added numbers, so say if we just had y equals x squared, we know that our graph is going to go through the origin, our axis of symmetry is just going to be 0, everything's going to be very simple. But as we add numbers, we know that we have to have ABC values, our axis of symmetry is going to change, our y-intercept is going to change. So that's what we're going to kind of be exploring today. So let's just rethink about all all of the steps that we just took to identify all of these characteristics, because you're gonna have to be doing them over and over again in our activity today. So, what was step number 1? I'm testing it, so I'm turning it over. What was step number 1?
Standard form.
So you decide if it's standard form, right?
Mhm.
Okay, and if it's, we know it's in standard form if we have what on the left? Y, and then what on the right? All of our terms. Okay, and they have to be in order. Okay, and once we have everything in order in standard form, what's the next step? Find our A, B, and C, good. And then after we find our A, B, and C, we can decide if we have a what? Maximum or minimum point. And if C is positive, we have a minimum, and if C is negative, we have a maximum. Good. Let's see. Then we're gonna find our y-intercept, and how do we do that? We can plug in x equals 0, or we can just look at our c value. Okay. Let's see. Then we have to find our axis of symmetry, and how do we find that? X equals negative b over 2a. Good job. Then after we get axis of symmetry, we can find our vertex, and you plug it in. Good job. And then what is the last step? X-intercepts. And then from there, we can put them all on a graph and connect our points, and we're good to go. So, today what you're going to be doing is I'm going to be giving you you're going to get a little piece of paper, and you're going to have an equation on it, and you're going to work independently to use your equation, identify all of the characteristics that we just went over, and then graph your graph. And after that, you are going to group up, and you have a little team name on your piece of paper, and you're going to group up with your team, and you guys are going to graph all of your parabolas onto one big graph and see how the graphs are kind of different and how they transform depending on what equation you have, okay? And you guys, you're going to like discuss, and you're going to come up with a conclusion and all that stuff, but we'll get there after you really dive into this. So I'm going to go ahead and start passing everything out. Yes, I would love some help. This activity is that you guys are going to present to the class what each of your teams found out about your equations and how it related and how it transformed. Okay? And before we present, though, what I want you to do is, we need to discuss things that we think are important when presenting. Okay? So what are some things that you think are really, really important to do when you're presenting well? Something that you want to do you want to get graded highly on when you're presenting. Ideas, just throw them at me, and then we're going to make a list. Projection? Like volume of your voice?
Yes.
Yes. So, volume. What else? Be loud. Yeah. Clarity. Clarity. So you want to be very clear.
If you're like watching someone do your stuff.
Mm-hmm.
Cheap out. You cheap face people whenever you're talking, you don't have your back.
Okay, so face out. What else is important? Eye contact, that's a good one. What about some other stuff? Yeah?
It might be good if you know what you're talking about.
Content, because you really want to know what you're talking about. And because this is a group project, we want to make sure that teamwork. Everybody needs to say something about what they learned. Okay?
Block it, make sure whenever you're standing, like, your whole group, whenever you're standing, make sure they can see what you're talking about.
Some other stuff. Let's see, I have some suggestions. What about wanna make sure that you include exactly what you're trying to explain, so your content, and then you wanna make sure that everybody has teamwork so that everybody knows what they're trying to understand. Mr. Duncan, do you have any suggestions as what to do in the presentation?
Not that I can
Those are all
think of.
pretty good ones.
Well, I guess if it's a group presentation, make sure that everybody has as much of an equal part as possible. So equality in the group, I guess. You know, math with like equations, equalities.
Okay, so let's decide on 5 that we really think are important. I think content would be my most important one. So I want you guys to make sure that you really explain what you found when you were doing this project, and explain it well, because it's going to be something that your classmates need to know and need to understand about quadratics. I also think equality is a really important one. I want to make sure that everybody has a chance to explain and contribute to the presentation. Everybody needs to have that opportunity to talk and show me that they understand what they are explaining. What else? What do you guys think is important out of the rest on our list? Teamwork? Teamwork's kind of like equality though, right? Yeah, volume, that's a good one. Okay, so we want to make sure that we're really loud and everybody can hear you.
Be respectful.
Being respectful, that's good.
Tell the stage what you know.
And then, that's 4, and then one more.
I think it would be important to be clear, because if you're just mumbling your words, then they don't know what you're talking about.
Oh, that would be volume. because you want me to
Okay,
understand.
we'll put clarity and volume, that's a good one.
Okay, what about seeing what you're talking about? So some people are more visual models than they are like other things.
Okay, so we want to make sure that our classmates can see our stuff. And then let's say that we'll put like eye contact and stuff up here with seeing. So like you want to make sure that you are looking out at everybody and you're not in front of the board, so that, or not in front of your paper that you're presenting, so that everybody else can see what you're talking about. Okay? So we'll use those 5. And so what those 5 things are the things that you're going to be graded on in your presentation. And so when you get back together with your groups and kind of quickly discuss who's going to say what and everything like that, you want to keep these in mind, because you want to make sure that when you're presenting, these are the things that you're going to hold yourself accountable for. Okay? So take like 3 minutes, 5 minutes, go into your groups, decide who's going to say what, and then we'll bring everybody's posters up and everybody go present. So just in kind of a summary of what everybody just talked about, I'm going to write it. Okay, so we decided that when an equation is written, y equals x squared plus a, and a is just any number, that means that it's going to cause our graph to move up a units, okay? And when we have y equals x squared minus a, it's going to cause our graph to move down because we have that negative a units, okay? Another conclusion that we drew was when we have y equals x plus a squared, so when we have plus a number inside parentheses, this plus is going to cause our graph to move left a units, okay? And when we have y equals x minus a squared, it's going to cause our graph to move right a units. Another team showed us that if we have a positive a in front of our x squared term, that's going to make our graph open up and we're going to have a minimum. And if we have a negative a in front of our x squared term, it's going to cause our graph to open down and we're going to have a maximum. And then the last thing that we decided was if we have our ax squared, if a is greater than 1, then our graph is going to end up being skinnier. It's because our numbers are increasing faster. And if A is less than 1, but we know that it can't equal 0, because then we wouldn't have a quadratic anymore. So if A is a fraction, if it's less than 1, then that means that our graph is going to get flatter or wider. Okay? And those are the transformations that you would ever see for any quadratic graphs. So